Mm, yeah, I think.
Yeah, I believe so because I tend to forget because this semester, as you know, I have other subjects, and your class is on a Monday, and Monday your class, and then the rest of the days I have other classes, and it's all mixed up. Not very good in remembering at this old age. I need to eat something, like to enhance the memory. They say the guamara mushroom or something. I don't know, but I never started taking that. Well, anyhow, just to remind, or maybe just for the sake of for me not forgetting to mention later on, next tutorial, which is tomorrow, please do tutorial 5, question 2, question 3, question 6, question 7, and question 8. So do remember that. Let me type in the chat just to make sure everybody remembers tutorial. Well, I will um, write it on the chat also if I remember. But if I do forget, please remind me. So all these questions are basically what we covered last week. Yeah, topics that we covered last week concerning the probability tree. I think I haven't assigned you any tutorial on that yet. So just nice. We do that tomorrow, even though today we're going to start with chapter 4. Yeah. So are you both ready? Any question? Do you have any
Uh,
question for me? Yeah.
so far, no.
Okay. How about you, Calvin?
No.
Okay. So if nothing, let us start. Let me record the session so that we can start the class. Yeah. Hold on, I need to. Can you hear the chicken and the birds outside? Can you hear the background noise? Because I left my window open.
Oh,
Um,
not at all.
No.
oh, you can't hear, is it? Because I'm so tired of turning on the aircon, and I want fresh air for a change. That worries me if the background noise is too much. That you can't hear, is it?
Yeah.
Oh, that's good. Okay, so then I would not switch it. I mean, I would not close my window. Then I shall continue. So there's only two of you. I hope Farah will be able to join very soon. So let me start the session. Good morning. Today is week 6, and today's date is 22nd of February 2021. Yeah. Um, yeah, we're going to do chapter 4, probability distribution, for the subject BAMS 1613, probability and statistics. So we are in chapter 4 out of 7 chapters altogether. So our progress is considered okay. We are on chapter 4, which is the either way out of 7 chapters. Our progress is good. Yeah. So what is probability distribution about? It's not new to you both. Yeah. Oh, Farah has joined. Good, Farah. Um, it's topics that you have learned during additional maths, and hopefully you did learn about it during your foundation or your diploma. If not, then today is a good day to get acquainted to probability distribution. if you did learn it during your previous education, then it's a recall session then for you today. Yeah. There are three methods we're going to look at in probability distribution. One of them, no, sorry, two of them are under the discrete probability distribution. Yeah. And one is under continuous distribution, probability distribution. The two that are under the discrete probability distribution are the binomial distribution and the Poisson distribution. And the continuous probability distribution, the one that we're going to look at, is the normal distribution. So all these distribution are basically relating to probability. But it's just that when we study probability, we know the values of probability, they are between 0 to 1. Same thing in probability distribution. The maximum value we're going to get is the value of 1, and the minimum is 0. That means you will not get a negative answer, and you will not get a value more than 1. But of course, when you multiply by 100, that would be giving us a value in percentage. Yeah, so it coincides. I mean, it's the same as probability. I mean, like when we did probability, when you multiply by 100, your answer will be in percentage. So same case in probability distribution. But just that, why do we study probability distribution? Is because if you recall in chapter 2, when we did the frequency distribution, all the data that we have is based on the total frequency. And basically, we would use that to find the mean, median, standard deviation, so that we'll be able to make comparisons, say, if you have two products. Yeah. However, it becomes a problem when the quantity is not the same. Say, perhaps product A, you only have 250 frequency, and product B, you have 300 total frequency. So when you have a different value in that sense, it doesn't give us a more accurate comparison. So by using probability distribution, of which all the values are based on probability distribution, that means we are changing the value into relative frequency. It's more accurate in a sense. Yeah. So that is why in every business sense, yeah, you would need to look at the data under probability distribution. That is one of the reasons. Of course, there are other reasons. Yeah. I hope that makes sense. I hope you all understand why we're looking at probability distribution. And as what I said earlier, we have three types that we're going to cover: the binomial, the Poisson, and the normal. Just as a sharing concerning with this topic, in Thai UC, students for the diploma business students, they only do binomial and normal. They don't do the Poisson. So for degree students, yeah, and also for the diploma computing students, they do cover Poisson distribution as well, but not the business students under the diploma program. Just to share with you guys concerning that. So yeah, we're going to start. I'm not going to start with the binomial and the Poisson as what you see in your notes. I'm going to start with the normal distribution. Yeah, so let's start. Any questions so far? All okay?
Okay.
Okay. Kelvin, okay?
Yeah.
Okay, how about you, Farah? Glad that you are able to join. Farah?
Sorry.
You were a bit late this morning.
Yeah.
Okay, never mind. As long as you can join, and I'm just starting the session. So I'm going to start with normal distribution, and normal distribution, as I mentioned just now, is a continuous distribution. It concerned with continuous variables. So of course, when we talk about continuous variables, it's a lot to do with data that involves with measurement, like centimeters, kilograms, the temperatures, yeah, things that we measured, yeah, or in other words, values that has decimal point to it, yeah. The accuracy of it is up to a certain degree of um, decimals, yeah. And currency is another example, yeah. So whenever we have that kind of data, as what you see here, like heights of people, temperature of the room, currency, all these examples are continuous variables, and therefore the suitable distribution would be normal distribution. Now, when we do normal distribution, you need to understand the characteristics of a normal distribution. And as what you see on the screen now, yeah, this is a diagram of a normal distribution, and you can see it is bell shape. What I'm referring to the bell shape is this yellow curve. Yeah, you can see here. This is the shape of a bell shape, and it's symmetrical about its central mean. That means you can see the vertical line here. That is the central position of the value of the mean, in such that under the normal distribution, the value of the mean, median, and mode, where all of them are the measure of central tendency, is directly at the center of the distribution of a normal distribution. And basically, the mean, median, and mode is at the peak, where the peak of the bell shape is where the location of the measure of central tendency, the mean, median, and mode. But for the purpose of normal distribution, we assume or we accept that the mean is only being considered in this sense. It is because if you remember when I was doing chapter 2, mean, median, and mode, you would remember that the median and the mode is not used for further analysis. Median and mode, it's the calculation of it stopped there, just to get the value of the median and the mode. But the mean, as I mentioned, is a good value to be used for further analysis. And this is one of the areas under the probability distribution that the value of the mean is used. So one of the characteristics of a normal distribution is it is a bell-shaped kind of diagram. Well, you can compare it to a polygon on a histogram, yeah? And the word symmetrical here, what does it mean? It means that on this red vertical line that's separated into two parts, that means this is the left part is truly identical to the right part. Symmetrical means they are identical from the left to the right, and in such that the mean, the horizontal line here, split them into equal 50% on the left and 50% on the right. Yeah, so this is one of the characteristics of a normal distribution. I hope that is clear. The second one is that if you look at the normal curve, you see this line here or this end, actually it extends indefinitely, getting closer and closer to the x-axis. Yeah, of course, for the purpose of our learning, I will not draw to that extent. I stop at a certain location here, but the concept of a normal distribution is that the characteristic of a normal distribution is it will extend indefinitely both direction on the left and on the right. However, it gets closer and closer to the x-axis, but it will never cut it. It never touches the x-axis even. So because of that reason, for the normal distribution, there is a limit of the values that we will consider. And just for everyone's information, I will talk about this again later. The maximum we're going to consider is to -4, and here would be 4. That means the value that we will consider is from -4 to 4 after we have standardized it. So remember that after we have standardized. So standardizing process is another area that you should remember. And of course, when I have -4 to 4 here, it is therefore in such that the value of the mean exactly at the peak takes the value of 0. So that means it's from -4 to 4. Okay. Then another characteristic is that, remember I mentioned about this part is 50%, and then the other part also 50%, remember that? So both are 50%, 50%. That is equal to 100%. So total area under the normal curve is stated here equal to 1, similar to 100%, of which I've already multiplied it by 100. But of course, all the area, we're talking about all this area here, yeah, under the curve, even the ones that is shaded in red, are representing total area under the curve is 100%, or in other words, the value of 1. It takes the value of 1. So I hope that is clear. Okay, so this is something, the characteristic that you need to remember. And when we're studying a normal distribution, we are using two types of parameters. One is the mean, yeah, as you can see, it's the mu symbol, and the other is the standard deviation sigma. In other words, the parameters that we use for the normal distribution is the value of the mean and standard deviation will be given, will be provided in the question. Yeah, some question, they might not give you the value of the mean or even the standard deviation, but they will give you the value of the percentage or the value in corresponding to the area. Yeah, so in that sense, we still be able to find the mean. Yeah, and the parameters, the mu, yeah, and the standard deviation is basically based on this function, the formula 1 over square root 2 pi sigma squared multiplied to the exponential to the power of negative x minus mu to the power of 2 and divide by 2 sigma squared. Now, this formula is the one that is used based on the normal distribution. But looking at the formula, it is very time-consuming, tedious to calculate it each time. As you can see, the formula is not an easy matter when, in fact, it is possible to us to calculate because we know how to get the exponential to the power of, right? But it is very tedious. So therefore, because of the, a lot of calculation involved here, therefore, thankfully, a mathematician in the past had derived a good table that provide us the usage of the table of the values that has been calculated to help, in education, so that we can calculate it very fast by just looking at the table. Yeah, so because of that, therefore, in order for us to be able to use that table, there is a condition though. As you can see here, we call it as the standard normal distribution. That means any normal distribution that is provided to us, together with the value of the mean and the standard deviation, we need to standardize it. And to standardize a normal distribution is a very easy process. The value given to us is x, but in order to standardize it, we label it as z now to indicate or to differentiate that it has been standardized, such that the value of the x you minus with the mean and divide by the standard deviation. So every calculation we start off by that. We need to start off by, before we can calculate the value of the x, we need to standardize it such that we need to minus the mean and divide by the standard deviation. So do take note, it is the value of the standard deviation, not the variance, because some question, yeah, they give the value of the variance instead of the standard deviation, and that is where a lot of students make careless mistake, because when they standardize it, instead of using the standard deviation, they use the variance. So that is a common mistake among students, as what I have observed all this while. Okay, so moving on. Any question for that matter so far? Is it okay?
No.
Okay.
Is
Okay.
it clear?
Yeah.
Yeah. I just would like to know, yeah, because have you learned about normal distribution before?
Yeah.
Okay,
think
so
so.
Noel had. Kelvin,
Yeah, I think.
you did. And how about you, Farah?
I think have, but I don't remember.
Yeah. If you had taken maths, yeah, definitely you have learned it. But that if I think since you already finished diploma and all, that was quite a while ago. So I'm not sure what you have covered during your diploma. But never mind. I hope with my explanation, I'll be able to do just that to ensure that all of you understand what is normal distribution, yeah, back. But if you have learned it before, then it should be very easy to remember back. Yeah. So far, any question from anyone? All okay?
Okay.
Okay. Yeah.
Okay.
Just to remind everyone as well, this is how do you say? Um, this is a topic, yeah, that you would expect in your test, which is in week 9. Let me see. I think I did. I tell you what will be covered in the first test? Did I say any information about the first test? Is it inclusive of chapter 4?
Can you remember?
I can't remember. Kan? I've completed the test already. I mean preparation of your coursework, but I can't remember. Very bad memory. So many things to remember this semester with 5 subjects and all. But anyhow, I will remind to you guys again, because as scheduled, your test, your first test will be on week 9. So now is week 6. So still about 3 weeks away. So this is the diagram of a normal distribution. Yeah. And as you can see, A and B on the diagram, you can see the peak is at this point. And of course, we assume that is your mean. And the area under the curve, let's say we want to consider 2 ordinates x equals to A and x equals to B. That means I want to find the area only that is enclosed within this space from A to B. We know the total area is 1, but of course, in this case, say we want to consider only this area from A to B. Therefore, the notation we use is the probability of x between A and B. Yeah, just to make sure you're familiarized that we write it as the probability from A to B. So remember, normal distribution is still under finding the probability. But of course, when we talk about the probability, it is similar to the word area under the curve. Yeah. So in a way, area under the curve is another area covered in the topic called integration. Do you remember integration? So it is also a topic that concerned with area under the curve. Yeah, but of course, when we talk about integration, it doesn't refer to a normal distribution. It refers to, you know, depending on what function you have, and you need to find the area under the curve of that function. But for normal distribution, this is the idea. Yeah, we have a normal curve, and we want to find the probability of the area between A to B. So I hope that is clear to everyone. And of course, the area that we want to find is referring to the, you know, in how many percentage is it out of the 100%? How many percentage that it enclosed on that particular two limits of a value only? Yeah. So yeah, let's continue. Now, how do we do that? So these are just a few examples that you have in your notes. And you notice that first thing in the example here, that it's not x anymore. It's all already in the form of z. So if you remember to what I explained just now, the z means we already standardize it. Yeah, it's a standard normal distribution. That means the value of x, we already minus the mean, and we already divide by the standard deviation. So this is why you can see in this example, it's already, how do you say? It's already in the form of a z. Now, another thing I want to share with all of you is that the usage of the table. So let me close this for a while and show you the table. Hang on now. You'll see everything that I have here. Chapter 4, right? And in your notes, you have it in front of you.
What?
Do you have your notes? I should have opened this file earlier, but I did not. So it does take a bit of time. My computer is a bit slow. Too many things in it. Oh, I opened it many times. So you can see here, this is the notes that you have. And let me go to the table. It's normally, oh, it's not given to you, is it?
No, yeah.
Oh, in your notes, it's not there. So do you have a, then it will be a problem for you to visualize what I'm saying. So that means I haven't shared with you the table. So hang
You
on.
search in Google.
Huh? Sorry?
Search in Google.
Oh, no, do not search from Google, because that would be a problem, because we do have a common table that every student need to use. So let me get it. I have the formula and table. This is the table. I will share it to you guys. Yeah. I thought you do have it in your notes, but apparently not. So what I have is this. Yeah, takes a while, very slow, my PC. Yeah, you can see this is the one. Um, and the reason why I do not recommend, you can search from Google, yes, of course, but the reason why I do not wish you to do that is because this is the standard normal distribution table that we use. And the accuracy of the table is only up to 2 decimal places. And the thing is, for this table, you can see on the first column here, is it big enough for everyone? On the first column here is the value of the Z. So that means here where my pointer is, where my arrow is the value of the Z. So if let's say the value is 0.1, you can see 0.1 is this, then we take the first value here, which is 0.4602. Now, if I want the value of 0.13, yeah, if I want the value 0.13, so you see 0.1 is here, and 3, I have to correspond to this value because here is referring to 0.03. So that means this value here, 0.13, is 0.4483. Any question, class?
No.
Okay, you're clear with the deriving of the value. Right. So this is how the table looks like. And notice that the diagram here, where my pointer is at, up here, you can see that the normal distribution here, it means the area under the curve, all the values that's stated here is in such that we are referring to this n. That means the u is the value that correspond to the u is responding to the values that we find from this table. Yeah, that means this is the area shaded here. I hope you can see where my arrow is. Yeah, and always remember it's on this on the shaded area. Yeah, so have to be um careful about that. And since all three of you are from different institution before, um, therefore we have to standardize that everybody use this same table. Yeah, in TAIUC we all use this same table. Right, let me get back to the notes, and as you can see, or rather, give me a bit of time so that I can share the table to all of you, so that it's easier. You can refer to the table. I don't need to go back. So let me share in the Google Classroom. Is that all right?
Okay.
Okay. So
Okay.
give me about 5 minutes to do that, and we'll return back to the lecture. Okay. Okay, so are you all here? Sorry about
Oh, yeah.
that. And you can check from the Google Classroom. The two tables are already shared to everyone. So you can check it from there. It's there, right? Can you access to it?
Oh, yeah.
And a bit of, it's stated at the top of the table as a subject code of another subject. Very sorry of that. I was trying to find a table that has no other subject's name, but unfortunately, that's the only one I could get as fast as I could. Yeah. Um, I really thought that in your notes, the formula, not the formula, the table is there. So apparently it's not. Well, anyhow, let's look at the first one, which is probability of z greater than 1.5. So for this, as you can see, I've already prepared the diagram here. And basically, if I want to find probability of z greater than 1.5, it is basically corresponding to the value of 1.5. The reason why we put 1.5 here is because if you recall what I said earlier, that under the normal curve, the center is the value of 0 after you already standardize it. And that means the value will extend up to the value of 4 on the right side. And on the left side, it will extend to the value of -4. So that is why we know 1.5 is on the right side of the normal distribution. Yeah, so since we want probability of z greater than 1.5, so greater than means it's an area that is enclosed as shown here. That means it is in this area. So if I get my pen, yeah, it is basically all this area here. Yeah, that is what it refers to. So in order to find that, you need to check out from the table, and just like my explanation earlier, you need to refer to the 1.5, yeah, and you should get 0.0668. So just to show you, yeah, how the answer is by going to this table, and the value we want to refer to is the value of the value of 1.5. So you can obviously see here, I cannot make it bigger than this. You can see 1.5 is referring to this where my arrow is. And I can make it bigger. I thought there's 2 decimal places. 1.5 is, as you can see here, is 0.0668. And that is the value that we refer to, 0.0668. Is that okay? That's how you read the answer. Okay?
So the shaded area is that one.
Yeah, 0.0668 is the answer. So that's how you read it. You look at 1.5 and the shaded area is 0.0668. So that is shown here. Let me show it to you. Back to the slide. And directly we just write the answer just like what you see here. Is that okay? Yes?
Okay.
Okay. Calvin, okay.
Okay.
Farah, okay.
Yeah, okay.
Okay, good. Now the next question is slightly different. We have z is greater than -2. And if you look at the value, it's -2 on the left side of the diagram. So you can see I've indicated here -2 with this indication on the left side. Yeah. And the thing is, it asks for greater than. That means all the area here is enclosed as shaded, because greater than -2, that means all this area. You follow me? That means all that area. So as you know, in the table that I shown to you just now, it doesn't cover negative values. So how do we find negative values? So in order to solve this, we use the concept of symmetrical, yeah, of which I can use the +2, yeah, and assume that it is the symmetrical on the other side. All right, is that clear? And of course, we know the total area is 1. So since the total area is 1, I can just deduct this value here, the one that is not shaded, meaning total area 1, deduct the one that is not shaded to give us the area that we want, the shaded area. So that means the working is involving with, because we have used symmetrical now, total area 1 minus this part that is not shaded, which is this, probability of Z greater than 2. Yeah, that means we deduct this part. Therefore, we can get the balance. And you need to check from the table for the value of 2. You can check, yeah, it is 0.02275. Yes or no? So you just have to deduct 1 minus 0.02275, and that will give you the value of 0.9775 as the answer. Any question?
No.
No.
Yeah. Calvin, any question?
No.
Yeah, okay. Yeah. Noel, clear? Noel? Didn't hear you. Noel? All clear, is it? Hey, what happened to Noel?
I think he like
Oh, the internet connection not good, is it? Okay, never mind. So I hope everybody understand how it is calculated. Now the next one is if it's less than 0.8. So you can see here 0.8 less than, that means all this area in A and B. I've labeled it as A and B. So for this, in order to find all that area in A and B, that means what I'm going to do is I'm going to focus on this small area that is not an area that we want, and we use total area of 1 minus the area of A minus the area of B. So this is not a good statement actually. Total area of 1 minus A minus B together is this, but actually that's the area we want, actually the A and B. So I'm using the total area of 1 minus this small area. Yeah, so this small area is probability of Z greater than 0.8. You can see 0.8 is here, it's greater than. So you just need to check from the table. 0.8 correspond to 0.2119. And when you minus 1 from it, you get 0.7881. Yeah, so that is how you solve this question. So far, okay?
Yep.
Okay.
Yeah. So another question, you see, I'm going through this almost similar but different scenario, yeah, just to help that everybody understand this now. the next one is probability of Z less than negative 1.5. So if I want less than negative 1.5, the value negative 1.5 is on the negative side. So that means less than, it's only the area that is labeled as A. So you see, I want negative 1.5, less than means this area. And you can see it's written here, probability of Z less than negative 1.5. But I can't find a value with negative. So again, we're using the symmetrical of it, which is 1.5 symmetrical is A here. So that gives us probability of Z greater than 1.5. So you see, instead of finding the negative, which we cannot get it from the table, we use the symmetrical concept. We take probability of Z greater than 1.5. It's the same area. Remember, it's symmetrical. And since we did that, therefore we just have to check from the table. Probability of Z greater than 1.5 is the one that, just like the one that we did, the first one is 0.0668. So this is just to ensure that you know if you have a negative value and it's less than, we use the symmetrical concept of it and we use greater than, then we refer to the table to get us this answer. Is that clear? Yes?
Yeah.
Okay, no question. And we also have, if you look at question E, the Z is between negative 1 to negative 0.5. So basically you can see, remember 0 is in the red line. So this refers to from negative 0.5 to the value of 1. The area we want is the area A. So for this question, again, we cannot solve it using negative. So we have to apply the symmetrical to it. So you see, when we do symmetrical, it means same area A, but now it's positive 0.5 to 1. So how do we find this? Is if you think about it, the area from 0.5 covers the whole area up to here. You can see my pointer here. All the area here minus with this area 1. That gives us a balance. It's like when you have, say this is a cake and you want this portion of the cake only. So first of all, what you do is you cut, because you want only that portion. First of all, you cut the cake only to this. Yeah, that big for the 0.5. And then followed by you cut this portion, the blue one, which gives us just the balance of the one that we want, which is this area, only this area. Yeah, so I hope that is clear. Yeah, so in the calculation of it, in order to find probability of 0.5 to 1, we are using probability of Z greater than 0.5. That means 0.5 is this big until here, inclusive of the area 1. So the Z greater than 0.5 minus with Z greater than 1. So that gives us the balance of the area A. So that gives us, if you refer to the table, 0.5 is 0.3085 minus with Z greater than 1, which is 0.1587, and that gives you 0.1498. Is that clear? Any question, anybody?
Oh, no.
Yeah.
No.
Okay, good. Right. So moving on to the next part. This time it's negative 2 to 1. So it's in between. You can see the area we want is A and B. So for this, how do you solve it? Is using the total area 1 And the -2, of course, we cannot find it because it's negative. So I'm using symmetrical corresponding to z greater than 2. And of course, the value of 1 is simply z greater than 1. So you see, I'm using the total area 1. I minus this part and I minus the other part to give us the balance of the area of A and B. So again, you just need to refer from the table. What is the value of z greater than 1? And what is the value of z greater than 2? And that would give us the value of 1 minus 0.1587 and also minus 0.02275. And when you calculate that, you get 0.81855. Okay. So same thing for the other one. We have 1.19 to 2.12. Oh yeah, just to remind everyone, sometimes when you have your x, you minus the mean and you divide the standard deviation, the value may be more than 2 decimal places. It could be 3 decimal places, it could be 4 decimal places. So when that happens, what you need to do, because our table is only for 2 decimal places, you have to round the value to 2 decimal places and we refer to that answer. Yeah, some of you might know the usage of the calculator to calculate it. Yeah, it's still okay. I mean, like, regardless how many decimal places it has, you know how to find the answer using your calculator. So if you do have that skill, it's okay, you can refer to the calculator. But if in case, yeah, you do not know and you are referring the answer from the table, remember to round the value to 2 decimal places, and that is the value that we check from the table. Okay, so for this question, between 1.19 to 2.12, you can see the diagram is referring to this area A. Yeah, it's positive, so it's on the right side of the normal distribution. Again, same thing like the question that we did earlier. You have to minus the nearer to 0 value, which is 1.19, which is bigger area actually, minus with the z greater than 2.12. That means this area is referring to this area, all this area where my pointer is at. And z greater than 2.12 is only this area. So you just minus them after you check out the value from the table, which are 0.1170 minus with 0.01700. And that gives you the answer of 0.10. Any questions so far, please?
No.
No.
Yeah, it's clear, is it? You know how to do it?
So is there no calculation at all?
No, well, the calculation is basically involving these. I mean, to identify how do you write this calculation. And then the rest of it is just checking out from the table. And you just have to do this minor calculation of just subtracting 1 with the values that you have obtained from the table. That's all.
Okay.
Okay. So the skill is to be able to read the answer from the table. Yeah, I mean, you must be able to identify what values does it refer to. And of course, calculating the value then. Yeah. So that is just a few examples. Let me check if there's another one. Yeah, this is example number 2 already. I know I've given you guys a short break just now because I was getting the table ready on the Google Classroom. But now it's already 10:05, so you guys deserve another break, yeah, before we start on the example 2. Yeah, so can we have another 10 minutes? So 10 15 like that, 10, 15, 10, 20, we come back. Okay?
Okay.
All right. See you guys in a bit.
just the way you are, the way you are.
all men to our will.
That's true.
Just don't
So
get
just win all the,
flanked.
just win all the defense rounds and we're good.
You guys don't understand. Like this
well-
defense side is gonna be really important. We have to get
Oh my
all the
God,
rounds on
wait.
defense here.
Oh my
Defense
god,
is
look at their
popping.
comp, guys. Guys, look at their comp.
Holy shit, they're doing a
I'm
real
so
comp.
surprised.
Holy dude.
Wait, this is their normal comp.
Yeah, no.
That's
Yeah,
that's
that's
the-
Then we do what?
we're playing like full retake A, so
And we
I don't
fight
know.
long B. We fight long B.
All right, let's go. Good luck.
Good luck, man. I air for us a chow early.
It's just
You
the
got
poggers.
ticks. Sees nothing.
Cypher,
I just-
they Cypher came. That's a hookah. One's coming along B. Get ready to flash. Flash.
Flashing.
3.
Two, three,
One
two
more.
more, two more.
One more.
Blind, 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 blind.
I'm
Could be
early rotating dice.
Two,
You
two,
should probably
two.
stay.
So,
Curse not
oh, yeah,
cheating.
my bad, my bad. Double only.
Last
Fight,
two,
fight,
last
fight, 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 fight.
Please,
One
one
more.
more.
I'm 5.
I didn't hit this guy.
I'm 20.
No, wait, don't die, don't fight.
I don't die, I don't die, I don't
I
die.
can hear you, I can hear you.
Oh, heal, heal,
Oh
heal.
my god, oh my god, oh my god,
I can
panicking.
drone as well.
Alright, just
Yo,
Yeah,
heal.
heal. Drone now. Heal me.
Droning.
Gotcha.
I go.
Do you have bomb?
We did.
He
got out
grabbed
now.
it. He
Yeah,
grabbed
but-
it.
Could go hookah.
Wait, you
No
can
way
grab
you're
this
still in the
after.
orb.
You can grab this after. My turret's watching
Bottom right
hookah.
clear. Left side clear. Okay.
You can grab this orb. I cover.
Can't hear.
Can you walk to heaven, Dyserson?
I have an arrow
You're
again.
blind at the moment.
I'm gonna play under hookah. You could probably leave me, Spence.
Alright.
Hey, smoke.
Oh.
Yeah,
it's
he
not-
can do that across the map.
It's
Hookah.
hookah. Yeah.
Nice.
What, dude? I just said A smoke.
There's no
man.
way
you
you
said
say
A.
A. You said
Smoke.
A. And then he
Smoke.
paused. You said
I said A
smoke. There's no
smoke.
way.
There's no way.
There's no way he's doing this.
All right, let me standard.
Hey,
Oh wait,
yeah,
sorry,
that's
Nicole.
smoke.
Nicole, sorry.
Nigga, can I
Yeah,
get
let's
your
play
ghost?
standard.
Yeah,
Can I
taking
get
my
your
ghost.
ghost? Thank you.
Um,
I'm gonna smoke hookah tube.
Yeah, I droned for long earlier.
Yeah, I'm gonna nade like right here. Maybe nade it.
Okay.
Alarm bot, shower.
For NIP, and Draken making his way very quickly up mid. They know that was coming. The smoke's come in. He's taken a blind shot through the smoke. He'll have to drop back and find another jewel elsewhere. Looks like they want to take over Boiler very quickly, and Kenny's going to have some angry ninjas in his face very soon.
Oh, that is fast.
Ninjas in his face very soon.
Oh, that is fast.
Put that in your pipe and smoke it
Think you get pretty high if you did.
very quickly, and Kenny's going to have some angry ninjas in his face very soon.
Oh, that is fast.
Angry ninjas in his face very soon.
Oh,
Kenny's going to have some angry ninjas in his face very soon.
oh, that is fast.
Quickly, and Kenny's going to have some angry ninjas in his face very soon.
Oh, that.
Angry ninjas in his face very soon.
Oh, that.
Okay,
Ninjas
hello.
in his-
Yeah, welcome back. Let's do example 2 now. Yeah. Are you all here?
Hi.
Okay, so this is an example of how the question would be like. Yeah. What you have is 200 people, and the 67 kg is the mean, and standard deviation is 7 kilograms. Yeah. In this question, it's given as standard deviation, not variance. Okay, so we can straight away use it. Yeah. And one thing about a normal distribution, the word normal is stated there, meaning the question will tell us that the random variable of that, that means what the question is about, follows a normal distribution. Yeah, like what you see here, the weights are normally distributed. And what we want to know is how many people have the weight between 60 and 74, and then more than 81, and between 53 and 88. So what do we do? Now, the first thing is to state what the random variable is, and the mean weight of 200 people is the random variable. So that is the first thing that you should do. You should declare what your X is, what your random variable is. And then you should state what the notation it follows. It is X follows a normal. N stands for normal, whereby the mean is 67 and the standard deviation is 7. But you should take note here that when we write the standard deviation value, we don't write it simply as sigma equals to 7, but we write it in the form of a variance. Sigma squared equals to 7 squared also. Okay, so I hope that is clear, yeah, how it is done. Always remember, it is written as sigma squared, which is equal to 7 squared. So this is how we write the notation for normal. I'm not so sure why is it written like that, but I guess it's better in a sense. I don't know, it's internationally written in that sense. If you check out a reference book, if you got time to check out, yeah. I don't know whether you guys can go back to the library already. I mean, can visit the library. But I know the admin staff, they are back in the office now. But only 30% staff are allowed, yeah. But students, I'm not sure whether allowed to go back to the campus. Well, I know all lecturers are still doing classes from home, not from the campus. Okay, so once we have declared that, yeah, we have probability of X between 60 to 74. That's the first question that it asks. And notice that it's still in the form of X, yeah? So we need to standardize it. We need to change the X to become Z. Then we can use the formula, the table. So here, the process of standardizing it, as you know, you just need to deduct the mean and divide by the standard deviation. So what we have here, you see 60 is the value of the X minus the mean. This is our mean, and divide by the standard deviation, which is just the 7. And now you see the X now has changed to Z. You see that? And then the next value is 74 minus with the mean and divide by the standard deviation. So you have to calculate this, which gives us the value between -1 to 1. Now notice here, it's already standardized. So it's just that to find this area, it's referring to, let me draw. I think I didn't provide the diagram here. I should have, but perhaps. So this is your normal distribution, yeah? So it's between -1 to the value of 1. So this is the area that we want. So what is the best way to solve this? As you can see here, is I'm using total area 1, yeah, total area 1 minus with 2 of the z greater than 1, because you have 1 here and another 1 here. So if you symmetrical the negative 1 to the other side, it's the same as the value of 1, z greater than 1. So that's why you see the value 2 multiply probability of z greater than 1. Because there's 2 spaces, we use the total area 1 minus 2 of the area z greater than 1. And therefore, you only need to check from the table what is z greater than 1. And the value is 0.1587, which you multiply 2 and 1 minus them. And that gives us 0.6826. Is that clear? Any question?
No.
No.
Yeah. Okay, moving on to the next question. Please ask if you don't understand certain parts of my explanation. Reason because I'm aware of how it is calculated. Yeah, so sometimes my explanation is based on what I know, and I did not, I was not able to, how do you say, detect what kind of difficulty students are facing in understanding this. So I really need you guys to let me know if there's any parts you don't understand, like where does this value comes from, how is it obtained. Let me know so that I'll be able to explain better. Yeah. So
Miss,
yeah.
the x normal at the top, should we write first?
Yeah. This is because based on the question given. Oh, you mean this one?
Oh, yeah.
Yeah. In the final exam, it is recommended. In fact, when you write your answer for normal distribution, it is recommended that you write this expression. Because there are some marking schema, there are marks allocated for writing this down. Some examiner, they did not specify that. So to be on the safe side, wouldn't it be better just to write it, because that's the proper way of writing the solution of this? Yeah. And we have been instructed to inform students to write it. It's a proper manner. But some examiner, they say, oh, it's okay. Students already use the value correctly in the calculation. So why bother to, give marks to this? But the proper way of course, to write the notation. But then, especially during finals, yeah, if I see students are able to use the value correctly, I wouldn't focus on this too much. But you see, I'm one of the markers, but there would be another moderator, another person who moderates the paper. So what if the moderator is a person who wants to ensure that it's this is written, then you might lose marks if you don't write this. Yeah.
Oh.
So to be best is just to write. It's not difficult to write anyhow, isn't it?
Okay.
Yeah. So the next one, is there any other question before I go to the next one?
No.
Okay. Yeah. Farah, you're doing okay? You can understand so far?
Yeah.
Okay. Do ask, yeah, if there's any question, and I hope Calvin also following okay. Yes?
Yeah.
Okay. So next one is probability of x greater than 81. So again, it's still in the value of x, so you need to standardize it. So you see x now becomes z, the 81 minus 67 divided by 7. And when you calculate this, it's the value of 2. So since the diagram is already z greater than 2, let me get my pen. You can see that if I draw it diagrammatically, oops, missed that part. So the 2 is here. So basically it's this area. So here you can simply check out from the table, and that gives us, oops, exactly the part where I draw the diagram. Let me erase that. It should be 0.02275 as the answer. Is that clear?
Okay.
Yeah.
Okay.
And the third question is from 53 to 88. So basically the same as question A, but when we standardize it, you'll notice that it's in between a negative value and a positive value. So this is from the example one, there is one example like this. So we have to use the total area 1 minus z greater than 3 minus z greater than 2. So just to help you guys to visualize it further, let me just draw it. Just a quick one. Should have done it earlier, yeah. Put the drawing in, but perhaps it's 3. So it's all this area here. So the best way is to use total area 1 minus the area 3, which is this area. Let me get my pointer, which is this area, and minus this area also. But since we cannot find from negative, we do symmetrical, which is z greater than 2. So you just need to check all these values from the table, and basically when you deduct them, you should get 0.9759. Is that okay?
Okay.
Yeah.
Okay, no problem. Now do ensure that you double check my answer as well. Sometimes I do make a mistake of typing incorrectly. So yeah, while you check out the answer, you know, I mean, you do the calculation as well so that you can let me know if I make a mistake. So that's it. Now, when we go to example 3, it's slightly different. Now, if you check out the Google Classroom, I have 2 tables given to you. Yeah. At the moment, we're using the smaller one. Sorry, the longer one. There's 2 tables, right? One is longer with a longer table, and one is shorter with a shorter table. Yeah. So this question, as you can see, is slightly different. All the while, let me go back again. All the while, we are given the value of x. You see, x here is from 60 to 74, and we need to find the answer until we get the value in decimal, 0.6826 here, for example. But if you look at this example, the next one, the x is not given to us. It's written as a here. Yeah, and what is given to us is the probability value already, 0.3783. So how do we find, or how do we solve this particular kind of question? So looking here, the first one here is probability of z greater than a. It's already indicated to us that it's a positive value, a. That means this is the position of a, and it's greater than. That means it's this area here. Yeah, so what you need to do is to refer to the value of the table. Yeah, and what you will see that the value is 0.31. So let me show it to you. It's 0 because it's given as 0.3783, right? Let me go back to this. 0.3783 and showing you the table. What you need to do is basically to look at this table and to search for 0.37, what was it? 3738 plus, what was it? 37, I can't remember already. 3738, was it? Oh yeah, 3783, was it? 0.3783. Yeah, here, 3783, right? This is the value given, 3783. So what you do is you just need to check from this table, the long one, 3783 is this value where my pointer is, and it's basically corresponding. Yeah, let me, if I can make it bigger, it would be nicer, but I can't make it bigger when I change my pen like this, isn't it? No, don't want to do that. It's too small for you guys to see. Let me make it bigger. So you see here, 3783 is corresponding to 0.31. You can see 3783. 0.3783 is this one. Yes, and it corresponds to 0.31. And that's how you get the answer very quickly. Yeah, so that's how the values is obtained for A. That's why the answer for A is 0.31. So knowing this is important so that you'll be able to, because sometimes the question will give you the value of the probability. Yeah, not the X to find. The probability is given to you. So you have to check from the table exactly the value 0.3783. That's how you get 0.31. Yeah. Now for B, it is probability of Z greater than A, but the probability value is bigger. It's 0.7823. Now for this, the checking process. For this, the next one, probability of Z greater than A equals to 0.7823. Now take note, 0.7823 is equivalent to more than half of the normal distribution. And we know the total area is 1. And to get 0.7823, it's more than 0.5. So definitely it will extend to a negative value. I mean, the area it takes is 78.23%. That means all this is 78.23%. That means the value of A definitely will be a negative value. Yeah. And why do we check from this end instead of from this end of the 78.23%? Is because it's greater than. So we refer from this end, and that would give us probability of Z greater than A equals to 1 minus 0.7823, because we're checking out the balance only of the area, which is about 0.2177. Yeah, if you minus them. So now the only value that we need to check is 0.2177. You need to check out from the table 2177. So I'm going back to the table. 2177 is this one where my arrow is. I hope you can see my arrow. It's at 0. It's at 0.78. Yeah, so I'm going back to the PowerPoint back. Slideshow it. And that's how we get negative 0.78. Don't forget to write the negative, because remember it falls on the negative region. Yeah, here is 0. On the right side are all positive value, and on the left side are all negative values. So if you do the checking, yeah, probability of Z greater than 1, negative 0.78, because our A is negative 0.78, just to do the checking, you know that when you draw it, it corresponds to this area, because Z greater than negative 0.78 correspond to this area. Negative, yeah. And in order to find that value, we have to use total area 1, symmetrical it, minus with probability of Z greater than 0.78. And of course, when you check the table for this, it's 0.2177. And if you minus it, you get 0.7823. So it is equal. Yeah. So in school previously, in your education previously, you might have learned it somewhere, a different method of calculating this. But yeah, no harm in you using that method. Okay, so same thing for C. If you check out from the table, find out what is 0.0793, you will see that the value is 1.41. Yeah, and you see it's negative because we're referring to less than. That means it will be, and if you look at the percentage of area, is only about 7.9. So definitely it will be on the left side of the table, no, left side of the normal distribution, and therefore it is the negative value. And for this one, look here, probability of Z is less than A, same thing, right? But you see the value is 97% roughly. So definitely 97%, it will extend all the way to the positive area of the normal distribution. So definitely your A will be a positive one. So you see probability of Z less than A, we are using 1 minus 0.9693. Why do we do this? Is because, let me go back to the table again. If you look at all the values that is stated here, the maximum it can be is, you can see, only up to 4. So if you remember when I was explaining to you about the normal distribution, the 0 is the center, maximum on the right is 4, maximum on the left is -4. So that's why the value is up to 4 only. And also, if you check the value 4, it's 0.0003, which is almost a value of 0. And as you go up, yeah, the value is still small, but it's increasing. And at the value 0.0, which is exactly at the position of the mean, is 0.5. That means half of it is 0.5. And the other half is 0.5 as well. So that's how, yeah, upon checking from the table, you would get, when you deduct this, you get 0.0307, 0.0307, of which we get the value as 1.87. Is that clear? Any question?
No question.
Yeah. All okay, is it?
Yeah.
Oh.
Okay.
Oh. Okay, good. If it's clear. Okay, so same thing for this, slightly different though, because if you look at this question, it is with the obsolete value of the Z. What does it mean? And it's less than, okay? It means that we are referring to the value of A from negative A to A correspond to 0.9. So if you think about it, let me just draw it, or better, I just show you the working. It means, I thought I didn't draw, the drawing is here. It means that the value negative A to A, all this area here is 0.9. That means what is the only balance left on the area not covered? It's only 0.1, but it's half, because half of it will be here. Another half of the 0.1 will be here. That means it's only 0.05. Yeah, so if we consider, or if we want to find the value of A, therefore probability of Z greater than A is 0.05 only. So I hope you understand why is it 0.05, because the value given of negative A to A is 90% already. So a balance of 10%, which is 0.1, and then you divide 0.1 by 2, you have 0.05. So you only need to check this part to know what is A, which is the same as negative A. So you have to check from the table what is 0.05, and it is 1.6449. Now, if it's greater than, notice here it's less than, right? That's why it's between negative A to A. If it's greater than, yeah, probability of obsolete Z greater than A, it's equal to 0.0602. It means that we have to consider what is the area for probability of Z less than negative A, which is equal to 0.0602, and the other one is probability of Z greater than A. So probability of Z greater than A equals to 0.0602. Now this is quite straightforward. You just need to check the value from the table, 0.0602. Okay, but this one, probability of Z less than negative A, is equal to 0.0602. Now notice here, less than negative A, that means we have to use the symmetrical, which again is the same as this value. Yeah, so therefore they are the same, and therefore checking out from the table, the A is 1.55. So far, okay, everyone?
Yeah.
Okay, good. Right, so any question? Kelvin, okay?
Yeah, okay.
Okay. Now this is another example, yeah? I hope the explanation just now was clear. This one is again normally distributed. The mean is 72. Standard deviation is 9. But look at this question, slightly different. Top 10%. That means it gives us the value of the probability. Yeah. And what is the minimum score that a student must get in order to receive an A? So notice here, the top 10% of the students receive A. So in this case, our random variable is the score on a final exam. We state out the notation, X follows a normal. The mean is 72, variance is 9 squared. So what the question is asking is that top 10% is 0.1. Probability of X, that's what we want to find, the value of X, which is less than, because minimum score, we want to know what is the minimum value of X. But of course, I don't use X anymore. I'm using K, a different variable, because our random variable is X. Since I want to know what is the new value in order to satisfy 10%, top 10%, what is the minimum score? Because the mean score is 72. So the minimum score to get the 10% of the students who receive an A is K. So you see, X is less than K because minimum score, yeah, of at least the top 10%. So what we do here is we need to standardize it. That means the X must be changed to Z, and K, you minus the mean and divide by the standard deviation equals to 0.1. Now this is where you guys need to refer to the second table. Let me show it to you guys. Second table, yeah. I don't have it. I haven't opened the file. So give me time to open the file. So this is it. Oops, too big. So you see here, class, we are looking at the second table. Now remember the value is 0.1. Yeah, 0.1 is corresponding to the 0.10. So you see all these are referring to the alpha, U alpha. So this table is basically referring to 10% this one also referring to, let's say you need to check 0.40%, 0.25. There's many other, all the alpha is referring to the percentage. So for our question, we only referring to 10%, which is 1.2816. So this time we are referring to the shorter table. Yeah, 10% referring to 1.2816. So let me go back to my slide. So 0.1, we replace it now to the value of 1.2816. Now, from here, we know k minus 72 over 9 is the same as this. And you might ask, why is it negative? This is because when we have a normal distribution, the question asks minimum score of 10%. That means 10% is only up to here. This is the 10%. This is the 10%. And that is the value of your k. And if you look at it, the value of k is on the negative side of the table. And that's why we put the negative here. So what we do now is we cross multiply 9 times negative 1.2816 and then plus 72. Yeah. And that should give you 60.4656 marks. So that's the minimum score that the student must get in order to receive an A. Based on this data, the mean is 72 and the standard deviation is 9. Any question, plus?
So far no.
Huh? Okay.
No, yeah.
Okay. Yeah. So of course, because it's concerning with marks, yeah, you can round it up. But remember, when you do round it up, make sure you still write the answer all in decimal places. But when you round it up, remember to use this symbol, approximately 61 marks, rounded it to the nearest whole number. Okay, so another example here, I'm rushing a bit because I look at the time, it's 10:53 already. Now, if I have x follows a normal 100 and the standard deviation is not given, yeah, we just have the sigma squared, and given to you that the probability of x less than 106 is equal to 0.8849. Now, notice the value here is more than 0.5. It's not available in your notes, in the table. We need to find the standard deviation. So for this kind of question, which you can expect to be asked also, is that we know the mean is 100. This is your mean. Okay, so for Z, so for probability of X less than 106, again, you got this from the question, equal to 0.8849, we standardize it. See, X now becomes a Z. 106 minus 100, because we know the mu is 100, over the standard deviation. We do not know what is the standard deviation. And basically, you see, it's less than 106. That means this covers all this area here, covers about 88%. The value given to us is 0.8849, right? So that's roughly about 88%, which extend more than half. So that's why our A is at this position on the right side of the normal distribution. So it's a positive value. Yeah. So here, in order to identify this, we cannot find 0.8849. So we have to deduct total area, which is a 1. That gives us the balance of this area, which is only, if you check it, I didn't write it here. 1 minus 0.8849 is 0.1151. So here, if you check from your table, 0.1151, let me go back. This one. You can see 1151 is this value, which is at 1.20. Notice that? So that is why we have 1.20 as the value now. Yeah, after you check from the table and you cross multiply, you have 1.2 sigma, and 106 minus 100 is a 6. Therefore, your sigma is 6 divided by 1.2. You get your sigma or your standard deviation equal to 5 then. That's how we solve it. Any question, class? Any question?
No,
Oh,
it's just all the same. Just need to look. You just need to know how to look at the.
correct. From the table, the correct values. Just need to be careful in that sense, lah. Yeah. So that's all for today. That's what I plan to cover for today. Because the next slide is already showing a binomial distribution. If we had extra time, I have some extra example, but unfortunately it's already 10:57 now. So I think that is a good point to stop. And next week we'll finish chapter 4. We'll cover the binomial and the Poisson. Yeah. So like I said, tomorrow's class, we have a tutorial. I did mention tutorial 5, question 2, question 3, question 6, 7, and 8. Am I correct?
Oh, yeah.
Yeah. So that's the one that we're going to cover. Oh, do I have it here? No, I don't have it here. Yeah. So that's the topic we're going to cover next. Oh, what am I doing? Never mind. All these are the extra example I wanted to show you. So do that. The tutorial question, we'll discuss it tomorrow. Okay. If nothing else, I think that's all for today. Thank you, everyone.
Okay.
Okay, Miss. Thank
Take care,
you.
Miss.
Thank you. See you tomorrow. Bye.